Excited to be here today. If it wasn't apparent from my opening slide and or the name of the talk, there are going to be a number of pop culture references. Apologies to those of you who don't have the same tastes as me. If you didn't grow up watching any of this stuff, when you see some of these slides come up, assume that they're super funny jokes. Don't ask the people around you, just assume that it's the best joke you've ever heard and laugh hard. You don't want to feel left out. So we're going to talk today about how we used Kubernetes and Vitess to fly across the police barrier from Azure to Kubernetes on Google, on GKE. So we've got Eleanor. So again, that's the, I believe, a Ford Mustang. I'm not a car guy, but I've been told it's a beautiful car. And in the movie, it's the car that Nicolas Cage is never quite able to steal. It's this dream that someday he's going to get it. It's his white whale that he just can never do. And that's what we want here is how do we avoid lock-in? You know, it's this dream, but there always seems to be one thing or another that forces you to stick on a specific cloud. And this is what the cloud vendors want you to think. It also made me think of Hotel California by the Eagles. You can check out anytime you like, but you can never leave. If I had a walk-on song, that's what I wanted to pick, but I didn't have that choice. So I kind of want to talk about some of the key reasons that I think that we all get stuck in cloud lock-in. Provisioning and auto-scaling. If you're using a specific platform, a lot of people are using RDS or whatever database platform because they are scared of hosting their own databases. Whatever queue, it's kind of in the same category as the database. How do you handle persistent storage? And then the real gotcha is this network egress. They let all this data in, but they never let it out unless you pay quite the price. All right, so you've picked your Heroku, your App Engine, your Lambda. Things are going great. And, it's great when you're just starting up, you're saying, whether you're a startup or whether you're just, an in-house skunkwork saying, we're just doing a proof of concept. I'm sure everyone has experienced, this proof of concept that sticks around for a decade. And it's so hard to move off. Same thing, you've got like all these hosted databases, but one thing that I think people don't realize is that you're paying on all three of the main cloud providers exactly twice what the cost is per hour or per day that you're paying for the equivalent VM of that same size, plus you're stuck with whatever options they've chosen to give you, which sometimes helps if you don't have a DBA, but eventually you're probably going to hit some point where you say, if I could only enable this thing or that thing, or the next version of Postgres or MySQL launched, and I really wish I could use X feature, but it's going to be 2 or 3 years before that hits one of these hosted platforms. And then queues, I wanted to get into just kind of real briefly. All three of the cloud providers have a similar setup on their queues. Amazon has separated it out into SNS, that's like a topic publish, and then their SQS, that's just a work queue. And you can choose to use one without the other. Similarly, Cloud PubSub has the same topic and subscriber mentality, except it's not optional. On PubSub, everything is published to a topic that has 0 to n subscribers for that. And Azure is the only one I haven't actually used, but they have their service bus that's the same topic to fan out to subscriber mentality. And then finally, we kind of get to this network egress that can get real expensive. I'm not actually sure. I didn't make this chart myself. I found it thanks to the internet. But all the cloud providers have roughly kind of that same egress cost. So let me go into a little bit of history about Nozzle. So what we do is we parse Google. We like to say when I'm talking to developers, I like to say we store Google on Google. So we parse search engine results, and then we provide SEO-related analytics to big customers that are looking to understand who's ranking where, why they might be ranking, and as much metadata as we can provide about it. So from the beginning, like I kind of mentioned, we did a proof of concept on App Engine. We're still on App Engine 6 years later. And then this logo here at the bottom is Cloud Tasks, which we actually have it's been amazingly stable. So there are definitely reasons that choosing some of these hosted products are great. But in our actual code base, the error for if a message fails to add to Cloud Tasks, it just emits, tasks are failing, the world is ending, abandon all hope. And luckily, we haven't seen that very often. But it's important when you have these queues, and they're the backbone of your entire architecture, and the whole assumption is that, oh, I can just write to Cloud Tasks or Kafka or whatever the thing is, and that will never fail. And so that's an important, always a key component of any infrastructure. And then this is how they really get you when you're a startup. They come in, they have their cloud startup credits. All three of these do. The other kind of cloud providers, DigitalOcean provides some as well. But that Azure number, I don't think it actually is the case anymore that they're providing this much. But this is my What About Bob reference. That Azure just swooped in with their bag full of money, and they tried to buy my loyalty. We had been on App Engine, but all of a sudden, oh, $360,000. Maybe this is good enough for me to try Microsoft. If it wasn't obvious from the title of the talk, it was not. So we started using AKS. This is a pretty good representation of what it felt like. When we started, it was a beta product, and so that was to be expected. But then, for some reason, they said, oh, it's GA now, despite it being exactly the same. Some specific things that made us decide to leave AKS. There was a 100-node limit, which may or may not still exist to this day. The docs aren't consistent on that. They also just barely added the ability to have separate node pools, which is particularly important when you want to run a database, because you're almost for sure going to want to run a different node type, size, and memory configuration than your standard workloads. Disks would take forever to mount, which meant rolling out any change to Vitess or to any stateful sets took forever. We actually had a 2-day outage while it was in GA because they just artificially throttled the CPU on our masters. And it took 2 days for them to figure that out, even with the support, the pro support contract. So that was awesome. And then finally, kind of the last nail in the coffin was the pricing. If you didn't, lock yourself in, was significantly more. And with that node pool, most of our workloads that we run are batch workloads, and so the ability to just use a preemptible node pool can cut our costs 70%. It's a spot instance basically for the AWS users in the room. Really made a huge impact on our costs without us having to commit to anything. So for all those reasons, we decided, let's get out of Dodge. But we weren't exactly sure how we were going to do it. Luckily, we had Kubernetes and Vitess that came to the rescue. So if we come back to kind of that original premise that I had, provisioning and auto-scaling, Kubernetes is obviously nailed. Running stateless applications is super easy, and you can spin up a new cluster pretty much anywhere, and that's not that hard of an issue to solve. But Vitess is really what enabled us to wholesale migrate and to migrate in 60 minutes. By the way, I actually watched Gone in 60 Seconds to prepare for this talk, thinking it was going to provide some metaphors or something I could use, but it's not a great movie. In hindsight, so. But it gave me a great opening slide. I was pretty proud of that one as a non-designer. And then the combination of Kubernetes and Vitess being able to handle some of that network egress. We were able to zip everything before sending it out. That gave us pretty good savings on, actually, we were still on our credits, so I didn't care about egress, to be perfectly honest. But that's only if you migrate out before your credits expire. I gave myself an hour, so I was kind of forced to be gone in an hour. So Kubernetes is obviously great. But I kind of want to talk about Vitess and exactly how its architecture lends itself to this way of treating your data and handling it in a cloud-agnostic way. So you start off, you have all of your apps that are running there, expected to point at a database, which is exactly how the architecture works. You point at a load balancer. In Kubernetes, it's just a service. And then it points at this VT gate layer that is a stateless component that will auto-scale up and down. That's what presents itself to your application as the actual MySQL interface. It also has a gRPC interface for that. But most people will just want to point at that MySQL protocol. And then once you hit this VT gate layer, that's where it makes some of these decisions about what shards specifically to look at. If you zoom in here on one of these shards, there's kind of this blue and orange. So VT tablet is a component that runs generally in the same pod as your actual MySQL process and is what actually communicates. So it's a gRPC internally from VT gate to the VT tablet, which then generally communicates over a localhost Unix socket into MySQL. So you get pretty low latency there. If you do work at a company that feels like, no, I have to put this data in Aurora or Cloud SQL because Kubernetes just can't handle stateful workloads, it can also do that. But for kind of the reasons I've said, you really, like Sugu said in his keynote, when you move to Kubernetes, don't leave your data behind. And then finally, so once you have your data here, your queries route through VT gate, they pick the correct shard, execute, and as far as your application is concerned, it's just talking to a giant MySQL instance. And then when you actually want to control sharding or do any cluster operations, it should feel very familiar to anyone with Kubernetes. There's a topology server that's not all that different from the Kubernetes API server, and then a VT control D that communicates with that and lets you run Vitess-related commands. On a side note, one of the original contributors to Vitess who then moved to Kubernetes, he actually snuck a commit in that into, I think it was the 1.9 release notes, that it is not kubectl. He gave the canonical way to pronounce kube control. So it's in the docs, and so it's canon. I'd prefer to not hear kubectl ever again. So this is how Vitess works kind of at a conceptual level from your application. But next I want to talk about what does it look like in a multi-cloud or a multi-region scenario. And I apologize, I did not design this slide, but I did design this one. So Vitess has the concept internally it's called cells that are going to be roughly equivalent to an AZ, but it's just whatever your data center or your blast radius that you want it to be. And then it has a global topology server. And actually, let me jump back here real quick. You'll notice that this topology server is not in the actual request flow as queries come in. And that's very purposeful because it's built to scale. Like Sugu mentioned in the keynote, JD.com is hitting 35 million queries a second on this. And for those of you who have ever run into etcd problems, that's not what it's not going to do so great if it was in a low latency flow like that. So there's this global topology server helps tie all these local regions together. And because Vitess is fully region aware or cell aware, it's assuming you get the Kubernetes networking set up correctly, it's fairly trivial on the Vitess side to say, okay, I have a cell here in Azure, I have a cell in these two failure zones in GKE, and another thing I didn't mention, so Vitess is single master, so you'll have a master living in one of those cells, but you can fail over at any point and reparent to another one of those. And so sorry, just checking my next slide. So we had a choice about whether we wanted to try and do a zero downtime movement, which would be fully supported in this scenario by simply reparenting the master over to GKE, and then all writes would be directed there. Again, assuming you get the multi-clustered networking taken care of. And then you just turn down the Azure region, and your apps don't ever know the difference. So it's pretty fantastic that way. And as you're doing those failovers, like I mentioned, it's generally a zero downtime reparent. So the database running in Kubernetes is handled. But this next one is a feature that's near and dear to my heart. It's the unsung hero that is Vitess Messages that I begged into existence about 2.5 years ago because I thought I was going to migrate much sooner to Vitess in Kubernetes. It was actually while HubSpot was, at one of the talks, they talked about how HubSpot was running 10 terabytes of general log to try and improve SQL compatibility. But apparently I'm a great beggar, and I got Sugu to tack on this much more fun to code Vitess Messages that's much more fun than increasing SQL compatibility. So it's the best. So all that this queue is, so it's functionally pretty similar to the queues that we looked at before. There's a topic that can fan out to subscriptions. So here, again, it's just a MySQL table under the hood, which provides a lot of benefits. You just make this specific table. This is an event stream message table, and then has a lot of the fields that you'd expect. What time was it scheduled? What's the ID? The next time it's going to run. How many times has it retried? And then you can actually add on this key space ID, attributes, data. That's what we use internally. But you can actually define whatever fields you want that makes sense for your message table, and those will all be delivered as a part of it. We choose, for tooling purposes, to hard code the specific fields so that we can have better tooling that handles all of the different data and columns. Depending on how you feel about foreign keys, I love them. They make operation a little bit harder, but it makes me feel better and less angry at my developers. And so it warms my heart. So you can use foreign keys just like you would anywhere else. And then down here in the comment at the bottom, this is where you define all of the actual queue attributes that you need to use. So the topic here points at the topic that it's subscribed to. The Vitess message lets you know that this is a message table and receives special treatment by the Vitess Message Manager. And then your ACK timeouts, how long you want your retention to be, and some other things. So it's very simple to set up, and again, it's a very simple MySQL world you're living in, which is completely vendor agnostic. And I see a lot of people, they kind of reflexively want to reach for Kafka or reach for Nats or something that's kind of a dedicated message server, which, those can be great technologies. But at the same time, now you've introduced a new stateful component into your setup, and now you have to have someone that understands that. Or if you're like some organizations, you just deploy data sources willy-nilly, and you just hope that they don't break because you don't have any internal expertise. But by pushing it through Vitess, you can say, okay, we understand MySQL, and we know how to make that scale. And by doing that, it's amazing when you can rely on a database transaction to both add data to the next queue, do whatever data work you need to be done, and then ACK that message back to the queue. And it eliminates a whole class of errors that could pop up from you have an orphaned record because either it got added to the queue and the ACK failed, or you did some data work, but then the queue went down, by relying on MySQL to enforce that transaction, you know that you just don't even have to write cleanup code for all those orphaned records. Another problem, with queues that we've seen in the past, it's hard to see what you have in your queue. It's hard to modify it in case something got added. And it's just SQL. You can requeue something with a simple update statement. You don't have to write some code to loop through and see what data you have in there. It's just SQL. And even if you need to manipulate the data that's in there, if it's something that can be expressed in SQL, you can just make it happen. And so I think that Vitess Messages is probably the best thing in the world. So now I wanted to dive into, okay, now that we kind of have this background on Vitess, how did we use that to get back to GKE? So like I mentioned, we had these two options. We could have figured out the cross-cluster networking, done a zero downtime. But like I mentioned, most of, and actually all of the workloads at that time we were running were batch. And so taking a little bit of downtime was an okay choice for us and seemed a lot simpler than trying to figure out this cross-cluster networking when it was just going to be a temporary solution. I'm also not a network guy. So we decided, okay, all we have to do is take a backup on AKS, turn things down, and restore on GKE. So to make sure that we minimize that downtime as much as possible, all we had to do was we spun up our GKE cluster. We set up those dedicated node pools that we never had on AKS. We just deployed all the exact same internal applications that they block on the DB connection, and so they never start. And then we use NGINX Egress, cert-manager, and external-dns to manage all of that for us. And we'll see in a minute how that kind of helped us to migrate pretty seamlessly and without having to do a lot of the dirty work ourselves. So then back on the AKS side, we scaled down all of our applications and kicked off the backup to GCS. So a side note, when we were going the other way and moving our 20 terabytes over from Google to Azure, we did it a few times, and we struggled to get that backup taken, transferred over, and then boot it up and have a running MySQL instance on the Azure side in less than 7 days, mostly because it just takes time to work at these big chunks. Where Vitess has a philosophy of 250 gigabyte shards, give or take. It's not a technical limitation, but it means that you can generally back up and restore within about 15 minutes. Since we were crossing clouds, we knew we were probably going to take a little bit longer. And so it was night and day, the whole transition experience. We also shut down external DNS. For those of you who haven't used it, you just set up some ingress annotations. External DNS watches those, and they integrate with whatever DNS provider you're using, and they point you at whatever the load balancer IP address is for the load balancer, the NGINX ingress that we're coming through. But since we were deploying it on the GKE side, we turned it down here so that we didn't have a race condition of them both trying to handle those same DNS entries. And if you don't have any external consumers and you're okay switching your DNS entries, it does have the ability to, you can kind of set a prefix. So you can say, okay, this is my AKS external DNS manager and my GKE, and that keeps them from clobbering each other. But in our case, we wanted our external and kind of our legacy applications that were pointed in at the cluster to not know the difference and to not have to do a redeploy to point at the new DNS entry. And so we did want the new cluster to clobber the original. So then on the GKE side, we had to bootstrap things. Like I mentioned, I'm not an etcd expert, and I thought to myself, I wonder if I can just pretend that didn't exist. and just let Vitess bootstrap itself. It's pretty good at it. And so I first tried, I didn't actually even take a backup or move that global topology server. So what I did is I deployed, after that backup had finished, we deployed the Vitess Helm chart, but only with one replica per tablet. That makes it easier for, you'll see here later, we run this tablet externally reparented to choose the master for every single shard. And that process itself bootstrapped the global topology server. And then when we scaled up the replicas, they were able to query that topology server and then auto-joined. And Vitess set up all the replication for those new replicas back to the master. And when that was done, I kind of thought to myself, it just worked. It's that moment when you were prepping for like this long battle, and then it didn't happen, and it just feels too easy. And I was just thinking that something was going to go wrong. The only thing that did go wrong was, also, side note, I saw a service when I was actually deploying that Helm chart that I was like, I wrote the Helm chart, and I was like, I don't know why I put this in there. I probably don't need it. So I took it out, and it didn't work. So when you are doing big migrations, don't change your configuration. Should be obvious, but I like to take risks, I guess. So honorable mentions to the Egress controller, cert-manager, and external-dns for making that, not having to manage all those certs. Everything happens over SSL, happened through those same DNS entries. And on Google Cloud, most of those provisioning steps for these happened within seconds to minutes compared to the tens of minutes to hours that we sometimes saw in AKS. So some future thoughts, like if you did want to run multi-cloud or even multi-region, again, as far as Vitess is concerned, it doesn't particularly care if you're in a separate region or you're in a different cloud, as long as your networking is set up and all the components can talk to each other. So there's a couple of cool things. There was a talk before given by Jiten and Deepthi about GDPR concerns. And you can actually set up your Vitess sharding strategy to be country or jurisdiction aware. And that provides some pretty cool opportunities to lower your latencies so that your clusters will all talk to their local masters. So you're not waiting for those reads or writes to go across the globe back to wherever your kind of home cluster is. But because MySQL does asynchronous replication, you can still put some, for safety, put some other tablets out in those other regions so that if, in the case that a region went down, you'd be safe and you'd be able to automatically fail over and have a master and basically not have, as long as your failover process is good, from the Vitess side, you wouldn't have any downtime. And then on the network egress side, MySQL does do compressed replication. And so if your actual applications are able to talk to their local versions of Vitess, you'll only have to pay that cross region or that network egress once in a compressed fashion as it replicates out to the various cells or regions. But then all of your application reads and writes after that point would be local to the zone or cluster. There's a lot of pretty awesome things that Vitess enables. And again, like I mentioned, once you do have that set up, it's pretty easy to reparent anywhere you want. Another possibility, CockroachDB actually has an interesting follow the workload feature where you kind of watch where the bulk of your writes, and it kind of generally follows the sun as you go through business hours throughout the world. So it'd be pretty trivial to then kind of move your master around between these multi-cloud or multi-region clusters so that the bulk of your operations, the master is closest to wherever those are happening. So anyhow, thanks everyone for coming. It was a blast, like I said. It was almost scarily easy to move across clouds. Luckily, it did take only an hour because my bill was about to come due, and I was not wanting to pay Azure any money. Any questions?
If anyone has questions, can you please come up to
mic.
the mic, please, for the recording.
How much data did you move?
It was about 20 terabytes.
Thanks.
Any other questions? Don't be shy.
You said everything took 1 hour to move. How many work hours for preparation of that did it take?
Should have taken more. I should have practiced. I didn't. So the reality was it was one hyper stress-filled hour. I don't know how many hours it took off my life. Sure. It's like a Princess Bride, not to 50. It was something like that.
Hi, we have a 24/7 operation. If we need to do this multi-cloud migration, is it possible to do? Because I noticed you actually took down the AKS site for backup.
Yeah, no, it definitely can be done. Like I mentioned, as long as the network is connected, you can just, all you would have to do is you can spin up asynchronously your tablets in the new cluster or the new region or the new cloud. And once those are caught up to master, you just do a reparenting operation that cuts over. And so it would be a zero downtime. We just didn't want to spend the time to set that up. But for someone that does have a 24/7 workload, it definitely supports that.
How big of a pipe did you have to enable between AKS and GKE to make it happen within 60 minutes?
I don't know. I just copied. So the Vitess backups, they by default write to, there's an integration to send it to GCS or to S3. And so it was, I think we had 50 shards at the time that were all independently writing to GCS. So I don't know what those exact limitations are, but it was big enough.
Okay. All right, thanks.
Any other questions? All right, if you have other questions, you can come up to the front afterwards. Thank you, everyone, for coming.
Thanks, everybody.